So I am going to start the session that is especially on Gen AI. That Gen AI actually in this session I am going to include these things, like first of course we will have introductory idea of generative AI and few other things related to generative AI. Then the most important type of model or paradigm in AI that we know as deep learning or neural networks, and then one important model that is GAN. For that we will be discussing, and then we will come to large language models or language models, and in which we will also discuss in detail about GPT-4 and recently launched DeepSeek R1 and these models. Then we will have we will discuss few things about prompt engineering also, that how it is going to change the job market especially. And then we will talk about future trends, and finally I will conclude because it is a 1 hour session. So I will try to include the most important things only to sensitize that how these things are important, and you should learn all these things in detail. So let's start with introduction to artificial intelligence. So AI actually refers to the field dedicated to creating machines capable of performing tasks that typically require human intelligence, such as reasoning, learning, problem solving, and even we can extend it to decision making also. So mainly AI actually include all these we can say domains, like we know as machine learning, neural networks, and natural language processing, and computer vision, deep learning, and overall cognitive computing. So all these are actually parts and aspects of AI. And if you will see the history of AI, of course it has been started modern AI from 1985 when AI graduate the courses. Then in 88 there was an international symposium on AI. In 89 Center for Artificial Intelligence was established, and then in 87 many of the industrial projects influenced by AI or based on AI has been launched. Then in 95 minor, master, and PhD in AI people were started doing. Then in 2000 there was a Mexican international conference in AI. In 2003 it was international joint conference in AI. Then in 2010 actually we have already started establishing the laboratories for robotics and all. Then in 2014 there were so many international AI research groups, and in 2015 there were so many competitions like KDD and all those things for related to which we have data on Kaggle and all those other dataset websites that has been generated through AI competitions. And recently, as you know, that in 2023 that chat GPT model has been launched. This year DeepSeek model has been launched. So all these things we can say are the events that actually shape the path of AI. So we just come to that why this generative AI has emerged in last 5 years, sorry. So generative AI actually refers to machine learning models that can create new content, and that content may be in terms of text or images, and even audio or video files also we can generate nowadays. So unlike traditional AI, which this generative AI actually focuses on recognizing patterns, and after recognizing patterns, this generative AI model generates novel data outputs. So in general, we can say that there is an encoder part where we provide input, and after that latent space representation and adding few noise, then with the help of decoder part, you will get an improved output or new output. So that is the actually basic working principle of any generative AI model. So where we can apply these generative AI models, so we can apply it in education, in teaching and learning, in healthcare for generating new images for particular disease, CT scan, MRIs. If we don't have ample number of data set, then we can use these generative AI models for creating these type of data sets to improve overall healthcare system. In finance also, in internet and entertainment and media, and it can be used in cyber security, as of course for content creation, whether it is for search engine optimization or any domain where we have to generate so many contents daily. There we can use these generative AI models in gaming also, and for virtual assistant also, like in terms of chatbot, as a chatbot where there will be a continuous conversation with the user. So in these areas we can use generative AI models. So what are the benefits and challenges? Of course, in terms of innovation, generative AI actually fosters creativity by producing unique content. So whenever we are struggling to produce some unique content, we can take help of this generative AI models. And of course, efficiency wise, it automates so many complex tasks and save time and resources. And what are the challenges? Of course, the ethical concerns like issues related to authenticity, potential misuse, and copyright, and all those things are already in debate with the emergence of these generative AI models. And of course, there is a challenge related to quality control, that how we will ensure the generated content meets the desired standard, because for that we have also to set the desired standard that the generated image, generated text is following or up to that standard or not, that we have to ensure. So these are challenges also. Of course, we have some benefits and as well as some challenges with most of the technological advancements. So it is also with this. Then two case studies I am going to take here. That first one is Microsoft Muse model. This model actually capable of generating video game visuals. So most of the game developers use this, and predicting controller inputs, enhancing game development and preservation. So for game development, developers can use this. And AI in chess. So as we know that advanced AI models exhibiting unexpected behaviors such as cheating when anticipating a loss, and highlighting the need for robust AI safety measures. So due to these examples, actually it is already in debate that we should be fixing all those things. We should have a framework to create all these safe AI models, that whether they are safe or not. So it is already in debate nowadays. Next, I will come directly to deep learning and neural networks, because it is a major player in this paradigm shift. That as we all know that the basic structure of a deep learning is especially that we will have some nodes that will be in input layer, where that input features will be provided or the input data will be provided. Then after that we will be having in between input and the final one, that we know as output layer, we will be having some hidden layers, and each layer will be having some number of nodes that we know as neurons. So these nodes or neurons will be interconnected, and with the help of mathematical models that actually is based on weights and biases, this overall forward propagation and backward propagation methods will be applied. And then finally this deep learning or neural networks can be used to predict or get some values for those input parameters. So this approach actually, let me tell you, that has revolutionized field such as computer vision, natural language processing also, and speech recognition, by enabling systems to learn from vast amount of unstructured data. So whenever we don't have structured data, then we can see that deep learning or neural networks have produced a great accuracy, and it is nowadays very much popular. So in terms of simple neural networks that we know as artificial neural network or multi-layer perceptrons, we know that there will be some input layer, as I told you, and in between we will be having some hidden layers, and finally we will have output layer. So all the calculations will be done with the help of these hidden layers. Some activation functions are going to be used to actually manipulate those weights and biases to get the proper output, proper class for output layer. And if we go through few steps ahead in this journey of deep learning, advancements in deep learning, Then we have CNNs, as we know that convolutional neural networks that are specifically very much popular for the problems related to image classification, and it has enhanced image and video recognition capabilities. Then we have RNNs, recurrent neural networks also, that actually improved sequential data processing. We have a sequence of data, so there we can use it, and that benefit the language modeling and time series analysis, where we have continuous data timestamp wise. There we can use RNNs and we can achieve good accuracy. Next, we have GANs that enable the generation of realistic synthetic data. For example, for a particular disease, only few CT scans or MRIs we are having, then we can use these GAN models to generate more similar CT scans or MRIs, and then we can train our deep learning models on those data sets. So this type of use or applications of GAN has proved that GAN is a very much potential these models have. And next pioneer in this journey is transformers. So transformers actually developed by the DeepMind team of Google, that revolutionized actually natural language processing by allowing models to capture long range dependencies in data. As we know that in conversation, what we have told 2 to 3 sequence earlier, that is also important. So that is going to be taken care, and on the basis of that, next output will be generated. So these long range dependency in data can be tackled with the help of transformers, and that transformer is the base model that OpenAI used for creating their GPT models. So next we will come to GAN, especially that in GAN, how this GAN actually works. Let's discuss that. GANs actually consist of two base neural networks that we know as generator and discriminator. So the generator creates data resembling the training set. So whatever we have in training set, that will be provided to the generator, and on the basis of that, it will add some noise, and then it will create an image after adding that noise to, and it will create that image, and that image will be provided to that discriminator network, that is also a neural network. So that discriminator will identify it or predict that this is real or a fake image, and if it has been identified it correctly that it is a fake and it was actually fake, then of course then that generator network will update itself and it will add some more noise, and this overall process will go on until and unless that discriminator is not able to classify it correctly. It means actually it was a fake image, but it was classified as real image. So this type of zero-sum game or adversarial process is going to be implemented in this GAN model. So as you can see that generator will produce synthetic data from random noise, and discriminator will assess that data authenticity and distinguishing between real and synthetic input, and this adversarial training process will go on until and unless both networks are trained simultaneously, and the generator aims to deceive the discriminator while the discriminator strives to accurately identify real versus generated data. So this overall process will go on until and unless we achieve up to a level of accuracy. Then that model's training part will be completed. Then we can use it to generate any new synthetic image. So of course in these areas we can use GANs, like in computer vision, in natural language processing, in as we know that autonomous vehicles, driverless vehicles, in medical domain, in geoscience, data privacy, related to generating some new audio and time series data. So we have different versions of GAN also, like DC GAN, style GAN, big GAN. So there are so many versions also that actually will be suitable for different type of applications. So that we may go in detail in next sessions. But before going further, let me show you some